All right, today we're talking about the ideal gas law. So we already have a bit of a handle on gas laws and how they work and how to run the math and the temperatures and what we have to do with that. So today we're talking about the ideal gas law. And the number one question that people ask is, when do I use this one? When do I use the other ones? If you look at the other ones, they all have a volume 1, volume 2, pressure 1, pressure 2, that kind of thing. This one will be one sample of gas that's not undergoing any changes. So no volume 2, no pressure 2, things like that. The other key difference will be that you're dealing with masses, because for all the other stuff, for mass, like a solid, we know how to find number of moles. For a solution, we know how to find the number of moles. We need to know how to find the number of moles for a gas. That's going to be ideal gas law. Okay, what's an ideal gas? Because if it's a law for ideal gases, what's an ideal gas? Well, an ideal gas is something that doesn't actually exist all the time. So the ideal gas law, as we do it, will only give us an approximation for reality. Love it. But the properties of an ideal gas. So the molecules are identical. Well, they aren't always, but we won't worry about these things. Particles have mass but no volume, which doesn't actually make sense. But if you think about a gas under normal circumstances, where the volume that the gas is occupying is huge compared to the volume of the actual molecule. So it works for a lot of cases. You can read, you can write this down, and then okay. Now this last one, molecules don't interact. Well, think back to intermolecular forces where we said they all do. So again, under normal circumstances, under normal gas circumstances, this holds mostly true. But if we were to like crank up the pressure or something like that, the ideal gas law starts to fall apart. Okay. Properties that don't really hold true and under all circumstances, we can ignore that. But the actual law, this is important. So this is where the stuff really gets to be important. Here is the formula, and I'll explain this in a minute. I'm just going to give you a second with that. PV, which we already know, nRT. And we could probably guess T, we know. R, we'll get there. Pressure. For us, pressure is always going to be in kilopascals. We know that there's other units, and you can use other units of pressure with this ideal gas law, but you have to make another change, and we're just not going to bother with that. Volume in liters. Volume has to be in liters. You've seen a lot of milliliter volumes. You would have to convert that to liters. Absolutely must be in liters. Number of moles for N. R is the ideal gas law. Now, it didn't really work out on the line split here. 8.314 liter kilopascals over Kelvin mole. Now, if that sounds like a goofy unit, it is. The purpose of that unit is to make everything work out. If you think about combined gas law, where you had, say, kilopascals on top, kilopascals on the bottom, Kelvin on top, Kelvin on the bottom, canceled itself out. Here, you don't have the second volume, the second pressure, the second temperature, so those kinds of units won't work out. R makes sure that they do. For us, the important part is the 8.314, and T, temperature in Kelvin. That's it. 8.314 liter per kilopascal per Kelvin mole. Not a terrible thing to commit to memory. Ideal gas law, PV equals nRT. Not a bad thing to commit to memory, but in most cases you will be given it. So if you're going to ask and you can't because it's a screen, there's your answer. In most cases you'll be given that information. Okay, now I'm not always solving for, well, I'm not even solving for anything there, but I need to be able to rearrange that formula. So I'm going to show you the ways this rearranges, but if you can rearrange a formula, you don't need any of this stuff because you already know how to do it. But I can solve for pressure, I can solve for volume, I can solve for I can solve for temperature, and I can solve for number of moles. I could solve for the ideal gas law constant, but why would I? It's a constant. Okay, so I'm going to show you a couple of kinds of questions that you're likely to see. Effectively, I can solve for any one of those things that I just showed you. They're all fair game. What sort of standard, typical kinds of things you're going to be asked? One is just information about it. Okay, it's kind of like what you had before. What was the new pressure? What was the new volume? Except, nothing's being changed. So you know something. Now I have a number of moles, and I have a volume, and I've got a temperature. Everything we talked about holds true. Temperatures have to be changed. The volume has to be in liters. So make those changes. I'm going to be solving for pressure, knowing the volume, knowing the number of moles, knowing the R, of course, and knowing the temperature. Plop it in, solve it, end up with that. Now, In this case, I am going to be given a pressure in kilopascals. If you don't like carrying units all the way through, you know that I do, but I generally don't insist on it, particularly with this one because of the value of R. Make sure you put correct units on it at the end. Putting the units that are supposed to be at the end doesn't mean that they're automatically correct. Just make sure you understand that. Okay, different kind of question. In this question, the one difference is I now have a mass. I was able to measure the mass of that gas, 640 grams of carbon dioxide. I need to know how much volume that is. Well, my ideal gas law is pressure, volume, number of moles. Ooh, I don't have number of moles, but I can calculate number of moles. Calculate number of moles using mass divided by molar mass. Hey, that's from way back, but I still need it. So now I know how to remember how many moles I have. I can put that in the formula using the rest of the information. So, ideal gas law, I'm solving for volume, solve it, get my answer. The answer will be in liters. Ideal gas law, volume is in liters, whether you're putting it in or getting it out. Okay, throw it up another notch. Molar mass. Now, it's a bit different because I have a mass, I have a volume, I've got a temperature and a pressure. I've got everything I need except number of moles. But number of moles is not the same as molar mass. Okay, so hang on to that mass for a minute. The information I have, the only thing I don't have for the ideal gas law is number of moles. There's nowhere in the ideal gas law for mass or molar mass, right? They're not the same. So I solve it for number of moles, keeping in mind about the volume in liters and the temperature in Kelvin and all that stuff. And I end up with a number of moles of 0.0027 moles. Well, now I have a mass and I have a number of moles. So molar mass is grams per mole, grams over moles. So now I can calculate molar mass. When would I want to know the molar mass of something? Well, glad you asked. Remember the gas, not the gas, but remember the simplest formula, the molecular formula? We needed a molar mass. And in those questions, I gave you a molar mass, but now I could just have you calculate the molar mass. We'll do questions like that in class. We'll build up to it. Anyway, that's all there is. Ideal gas law. Too easy. Talk to you in class.